Thanks everybody for joining us today. We're here at the Reed Training Center, MESTEC training facility in Westfield, Massachusetts. I am Jim Bashford, National Sales and Training Manager for SpacePak. We're in the process of updating our training facility here today. One of the things on the list is to replace our current Solstice SE 3-ton chiller with our new Solstice Inverter Monobloc chiller. Okay, notice a couple things to bring to mind here right away. We have a considerable size difference, right? We actually have more BTU output on our smaller physical size unit than we do on the current unit. Both 3-ton compressor, 3-ton capacities plus. So we're going to go through today some of the basic setup of the new inverter series, from basic piping to wiring schematic, wiring control wiring, as well as pointing out some of the basic components inside the unit. What are you going to see when you take the blower door off or the cover off here? What are you going to see when you take the electrical panel door off? And we'll go through it that way. This is our new inverter driven air to water heat pump. This is the SIM036, so Solstice Inverter Monobloc. This is a monobloc air to water heat pump, inverter driven with a Mitsubishi inverter compressor. BTU capacities up into the 40,000 BTU range, both heating and cooling. We can tell nominal size of this unit, the actual physical size is small. We also offer this exact same unit in a 5-ton model. Okay, so 3 and 5 ton of the inverter series. Stay tuned because SpacePak is doing some really big things. We're expanding our air to water heat pump line with a split inverter system, as well as down the road in late 2021 to expect an inverter version of the LAHP unit. While we're in the process of swapping out here at the training facility in Westfield, Massachusetts, we're going to go over some of the major components and parts of our new Solstice Inverter Series monobloc air to water heat pump. So coming right out of the box, we've got a unit, single fan. If you were to go ahead and take the front cover off of the unit with a screw that I've already loosened up, we're going to reveal the inside of the unit. Now at first look, not too cumbersome. This is where we will find our bag of goodies. We'll have our control, our vibration dampening bumpers, our control wiring harness, as well as our installation manual. This point as well, I'll point out a couple of components. So as we look inside, we know that flow is important to air to water heat pumps. Our current flow switch on this unit is located right here at my fingertip. Okay, if we were to look around to the right side of the unit, we have our inlet and outlet water tappings. Okay, they come with little plugs, dust covers to keep anything out. We know now that the water inlet is on the bottom and the water outlet is on the top. These are 1-inch female thread tappings. The next size up in this series, the 060 series, the 5-ton, will have 1.25 inch tappings, where this one currently has the 1-inch tappings. While we're on this side of the unit, this is where all of our electrical connections that we need to get to or we need to access. Cover will come off. Very nice and easy to access. We have our low voltage control. We have our remote on off, remote heat cool. This is where we're going to tie in our circulator pump. Okay, our circulation pump will be tied right in here, as well as our auxiliary output. If we look up to the left here, we'll see where we're going to land our 230, 240 volt connections. Okay, a couple hot legs, a ground, and a neutral. We take the cover off here. If we walk around back to the front, show some access to some other items that may be of importance. One of the other control is our touchscreen control. We have a wiring harness for the touchscreen control, and that'll be accessed right through the same side panel. We'll bring that out later today when we plug in our actual touchscreen controller. As we look down from the top here, when it comes time to commissioning the system and bleeding out air within the system, we actually have a thumb valve air port right here put a little rubber hose on that, fish it out, little thumb screw. That'd be the highest, in most situations, the highest part of the system and the best place to get the air out of. Also on this SIM Series 36 model, we have the option to add an immersion well heater, similar to the other 3 and 5 ton series Solstice units. Going a little deeper, now under general control, general installation situations, normal contracting, basic installations will not have to access this part of the system up front. However, it's important to show you what's in here. We take this cover off and we kind of get into the brains of the operation as well. We have a few more connections available at different times if required, control boards and things of that nature. It's up here, relatively out of the way, nice and clean and neat. But as mentioned, anything that we need to get to for our basic installations and upfront commissioning can be accessed either through the front or through the electrical side panel. So bringing us back to a few more of the components within our SIM Series inverter heat pump, we've got our inverter, Mitsubishi inverter compressor located here center of the unit, electronic refrigerant valve right here front and center. A little bit further in the back, we mentioned it earlier, we have the flow switch. Okay, flow switch is going to prove before we can actually start the unit up. And then even further behind that, a little bit harder to see, would be our 3-way valve, right? The valve that would make that adjustment, yep, far in the back there where those two blue wires are attached to. That's going to make the difference in the deciding whether we're going to be running our system in heating mode or cooling mode. We'll go ahead right now, and as mentioned previously, the bag of goodies, so to speak, that comes with it. We'll start to kind of stand in front of it here. Our control wire, our touchscreen control has come standard with all Solstice series heat pumps are vibration dampeners to go under the 4 points of contact for mounting the unit. We have our new touchscreen control that we will soon be powering up with wall mount. Okay, that comes with the unit as well. We can separate it. One of the great features here is that our control unit, we can essentially take it and carry it with us. So we mentioned earlier, we have the connection for control here to the left. If we were working outside with the unit, we can plug in this connection here, make adjustments to the unit while we are outside. We could also take the supplied 65-foot cord, hook into this unit, wire back to the mechanical room, take this control with us, in turn mounting it back in the mechanical room and be able to make adjustments while we are in the boiler room. Any of the adjustments made are not saved in this unit here. They are actually saved in the main control board. So for instance, there is the opportunity, even if it, for installation or some need requires it, you can make all of the settings and changes that you need in your unit and basically unplug this unit and not even have it connected to the unit while the unit is running. So this can be used either outside or permanently mounted inside. Now, it comes shipped standard with 65 feet approximately, might be 64 or 66 feet of control wire. We also have a supplemental piece that, not supplemental, what's the word? What's the word, Dan? So during the installation process, if we find that the 65 feet that we ship standard is not quite long enough for your particular application, this unit can actually be distanced from the controller up to 600 feet, okay? And if that is the case, we need to stretch it out over our 65 feet. We have spec'd out a suitable equivalent as far as the wire is concerned that we can use. So that'll be listed right on our spec and data equipment sheets. Also coming with the unit is a small installation manual. Full color installation manuals are available on SpacePak.com website, as well as through your local wholesaler and or local rep. Okay. So So we have finished our unit swap out here at the Reed Institute in Westfield, Massachusetts, SpacePak training headquarters. Bring ourselves right down in here. We'll kind of go over what we did to lay out our line voltage wiring as well as our control wiring. You can see here, as described earlier in the video, we have 240 volts, 220 volts here supplied to this unit. 2 hot legs, a neutral, and a ground. Now it's important to make sure that we use a neutral. We want to use a neutral because we need that to assure the proper operation of the system's circulator, right? The circulator that's going to be placed between the heat pump itself and the buffer tank. So again, we just want to be sure that we have a neutral installed in the system, neutral and ground. Now, if we go to the low voltage control side, you can see that we've landed 4 18-gauge wires, 2 on the remote on-off and 2 for the remote heating and cooling. So just as they kind of explain, an open and close on terminals 18 and 19 will decide if we're going to be on or off with the unit. And then an open and closed on terminals 20 and 21 will also say if we're going to be in heating or cooling mode. Now this particular unit, closed would be in heating mode, and open contacts are cooling mode. So if something ever happens to a wire, it would actually fail open or fail into the cooling mode. So that's something to be aware of. Just to the right of that control, we do not have it hooked up currently, but that's where we would pick up our 110 volts required for that circulator pump. Now remember, we do need that neutral landed on the main bus bar so that we can properly operate our 110 volt system circulator. As mentioned previously, we also have our communication cable here with a connection. Okay, male-female connection that would go into one end of that previously described 765-foot lead. Okay, once this is all set up, we've kind of hooked everything up here. We know we're ready to go. We can close it up. We're going to leave it open up for now. We're going to go ahead and hit the main disconnect switch, and then we're going to bring our attention over here. We've remotely mounted the actual control for the unit. So one thing to keep in mind, when this control is in a black and white screen, when the control is in a black and white screen, it means there is no call coming in. There's no heating call or cooling call coming into the system. Okay, we have our systems here hooked up to the SpacePak system interface control, or the SSIC control, if you will. We're going to enable the buffer tank for this unit. So in enabling the buffer tank, it'll allow us to maintain a buffer tank temperature. So we're going to go through a couple of items here. Master zone, there's an error because we haven't chose what a master zone is. We're going to go to buffer tank, select again, enable our buffer tank, select again, and then back out. Now our system is going to be cooling. Our tank is going to be looking for a cool temperature. Now if we bring our attention back down to the lower control, you can see that the screen has in turn changed color, and we can see a nice brightly little blue snowflake there in the unit. That's telling us that we have a cooling call being applied currently. To the right side of the screen, we can see that our inlet and outlet water temperatures are being displayed, both of the same temperature, okay, because we've started circulating water. However, we have not turned on the compressor yet. If we take a walk a couple steps back to the unit, we can actually see that this unit is currently, the fan is running, okay. If you cannot particularly see that, feel free to just assume that we're telling you the truth. Fan is running. We're currently running circulator to prove flow. In your initial setup, one of the things we have to do is decide how are we going to control the heat pump. Generally speaking, there will be another unit or another control, be it our system interface control, which is not part of the SIM unit. However, it is part of our product offering as far as our controls are concerned. So in this instance, we are using this. This is basically an advanced aquastat. It allows us to monitor outside air temperature, tank temperature, buffer tank temperature, and based on those factors as well as water temperature in that buffer tank, decide if we're going to use our heat pump for heating, or if we're going to, maybe if it gets too cold, or we can then switch over to our boiler, either based on outside air temperature or even time or actual tank temperature. So right now we can see that we're bringing a cooling call in. Now, one of the things to make sure of, when we go to settings, okay, we're going to click on settings. Under very initial start, we're going to go to status here. It's going to kind of give us an overview. Unit status is on, cooling mode on. It's also going to give us a quick rundown, our inlet and outlet water temperatures. So we're bringing in 49.1 degree water, and we're outletting 48 degree water. So right now we have a 1 degree delta T, which it may not seem like much, but being an inverter driven unit, we actually start slow with the inverter frequency, right? So low speed, and then we slowly ramp up to high speed. Now, if we were to go into our factory settings, now factory settings that you're going to want to access would be factory setting number 22. Press enter. Now we get into the parameters, we get into unit state, brightness, and then if there was ever to be a fault, we'll just jump right to that. Now, if there was ever to be a fault, the most common fault being something associated with flow, we would press this button and it would show right here very clearly there was a flow fault on this date at this time. Okay, now flow faults can be automatically corrected. Potentially even an airbound system which might have adequate flow but then drop the amount of flow and then could return to flow, right? If that air blockage has kind of moved down the line, it would still show you that there was a failure and it will log it for you. Now, if we were to go straight into the parameters, we know we have a cooling call right now. There's two separate ways to set up the unit. The most common way to be used is there's a master and a slave mode of the unit. If we were to click on this, we have master and slave. Now, slave mode being one is the primary, is how we will primarily set the control up. That is stating that we will accept a call from an aquastat or SSIC control, a thermostat. Okay, we're going to accept a remote call. That is going to be the 9 times out of 10 way that we will set the control. Now, when it comes factory, when it comes right from us, when you initially turn that unit on, it will absolutely be in master mode. You'll have to go in, click on the master slave HO2 parameter setting and change it to the slave mode. Okay, as we kind of cycle through everything else, we have a heating set point and cooling set point. If we want it, we look at our heating set point now. Currently it is at 46.4. Understand that the 46.4 is the return water temperature, so we're actually discharging much colder temperature. But so if we wanted to say, I'm going to make my return water temperature 50 degrees, enter. That's where we're going to be. If we want to say, oh, let's make it 40 degrees, press enter, it's going to just drop it down to the lowest point, which is that 46.4 degrees on the return water temperature. And generally, depending on flow rate through this inverter driven unit, we are going to deal with anywhere between a 4 and a 10 degree water delta. So keep that in mind. And that's something, as we get deeper, we can, our team here at SpacePak can work with you on understanding that. Same thing with heating set point. We can choose 120, 130. Okay, right now, again, we're dealing with 122 degree return water temperature, which is going to supply basically 130 to 132 degree supply water temperature. Okay. Now we have running mode as in ordinary. That would be the mode that the circulator is in. Okay, it's either ordinary, special, or interval. We are going to run it in slave mode as ordinary. Those are really the most important first steps in getting your system to run. Everything else, as we can go very deep into this control, is not necessarily required for basic systems, basic heat cool systems. Now we can change brightness parameters. We can now go to unit state. Now remember, we're still in number 22, or passcode 22 if you will. This will give us some more information. We've got our circulator pump on, we've got our compressor on, we've got no antifreeze heating strips, we've got no crankcase heaters, auxiliary electric heater, all of that kind of stuff is off. Switch status, high pressure switch is closed. These are refrigerant. High pressure switch is closed, low pressure switch is closed. Our flow switch closed, remote switch closed, mode switch is open, that's why we're in cooling. DHW, now we won't talk much about domestic hot water on this video, but in time we will have a video more associated with using our air to water heat pumps for some source of domestic hot water. And then our heat cool on off. Now we go to temperature status. It'll show us, okay, we've got an inlet water temp of 46 degrees, an outlet water temp of 44, exhaust temperature, which is a refrigerant exhaust temperature. We also have suction temp, coil temp, ambient temp, a lot of information on here. Something that we know here right now, we're currently running at low speed, right? Set frequency is at 30 hertz. Our actual frequency is at 30 hertz, I'm sorry. The range can go anywhere from 30 to 90 hertz. Also fan speed. This SIM 036 has one fan. We're currently at 310 revolutions. Okay, we can go up as high as 850 and as low as 100. Same thing again. One of the things that is really kind of slick here is, we know our input voltage right now, this is real-time information. Our input voltage right now is, we're looking for 230 volts, and that's what we're getting. Our current amp draw of the unit, so this would be in place of necessarily putting your own amp clamp on the system. It shows you right here, this unit, current running state at 30 hertz, is pulling 2.6 amps of electricity. Okay, really kind of great information for you to just look at on the fly. And then we can look at a couple other settings here. Module activity temperature, those are things that we're not necessarily going to get very deep in. But some really great information on the first level of control here with our touchscreen. And as we back all the way out to the front screen, again, we can see that we have a snowflake. We're making our call. We've got our inlet and outlet temperatures. Again, remember, we've kind of been turning this unit on and off a little bit, so we have maintained in that 30 hertz range, that low speed range.